Okay, so my question is from homework number 1, number 15. So the question reads, a spherical wave with a wavelength of 2 meters is emitted from the origin. At one instant of time, the phase at r equals 4 meters is pi radians. At that instant, what is the phase at r equals 3.5 and r equals 4.5 meters? So first, what I like to do is figure out everything that is given to me in the problem. So let's start from the beginning. So it says a spherical wave. So this already lets us know that instead of being like 1D conditions, it's going to be in 3D conditions because it's a sphere. And so that means instead of using like change in x, we're going to use change in r for because it's going to go out in the radial direction. And we already know that the wavelength is 2 meters, and at one instant of time, the phase at r equals 4 meters is pi radians. At that instant, what is the phase? So it's saying at one instant of time, and then at that instant, what is the phase? So it's telling us to use this as like a reference point, and then telling us to go from there to these instances and figure out what the phases would be. So then that's telling us that this is going to be a phase difference question. And so I'll write down my knowns and unknowns. So knowns, we know that the wavelength is 2 meters, that phi 1 could be, this would be that one instant, so this would be phi 1, and then this would be r1. So phi 1 is pi radians at r equals 4 meters. And what we're trying to figure out is what phi would be at r equals 3.5 meters and r equals 4.5 meters. So these are knowns. And then if you look at the equation sheet, you would know to use the phi difference equation because that's what we figured out this question is really asking us. So that equation is change in phi is equal to 2 pi change in x over lambda. But as I said before, this is a spherical wave, so it's going to be in 3D, so it's going to be 2 pi change in r over lambda instead. So at this point, you can just plug in your values into the equation. So change in phi is also equal to phi 2 minus phi 1, and then this is equal to 2 pi change in r over lambda, or I guess we could simplify this just to make it more easy to understand, r2 minus r1. So this would be like our r1 and then 2 and then 2 for the second time we do this equation, because we have to do this twice for like comparing this one to this one and then this one to this one. So I'll just do this one first. So we're solving for phi 2, so I'm just going to move the phi 1 to the other side, so then it's going to look like this, plus 2 pi r2 minus r1 lambda, and then once you plug in those values, you get pi plus 2 pi, and then r2 is 3.5 meters minus 4 meters for the first one, over lambda, which is 2 meters. That ultimately gives you, these 2's cancel out, so it's be pi plus, and then this will equal negative 0.5, so it'll be pi plus negative pi over 2, and that will equal pi over 2 radians as the phase at r equals 3.5 meters. So that's one answer, and we just have to do it again to the other instant. So we can just like copy this equation again. So it's going to be phi 2 is equal to phi 1 plus 2 pi r2 minus r1 for lambda, and then once you plug it in, it's going to look like this, pi plus 2 pi over 2 meters, and then 4.5 meters minus 4 meters. These twos cancel out once again. It's equal to 0.5. So this time it's going to be 1.5 pi radians equal phi naught at, this time instead 4.5 meters at r equals 4.5 meters.